Yeah, let me share my screen. Okay, one second. Yeah, I hope my screen is visible for you, everyone. And let me introduce myself before starting the related things related to webinar. And my name is Shiva. So I have overall 8+ years of experience in industry. I work with multiple technologies like AWS, Terraform, Docker, Kubernetes, Jenkins. I also work with Spring Boot applications. And yeah, I also work with multiple production-based issues and deployments and security, multiple things. Okay, it's like that. Okay, and I hold multiple certifications. A few examples are AWS Developer Associate is the one, and Certified Kubernetes Administrator, and Terraform Associate certifications. So this is my short introduction about myself. So yeah, now, today's webinar, what we are going to discuss is, let's go through the webinar content. So we are going to discuss about the projects that we are going to do in the course actually. So there is a course that will be going to be happening from tomorrow. For that course, what actually the projects that we are going to do in the as part of this course, so that we are going to discuss as part of this webinar. Okay, so that's the thing. Now the course is going to start from tomorrow, that is 9:30 a.m. morning. Okay, that's a timings that is fixed. Okay, now what's a webinar projects is related to the course is entirely related to Jenkins, Docker, and Kubernetes. Okay, Jenkins, Docker, and Kubernetes. So these tools were popular in industry in order to automate deploying and securing your applications actually. So everything will be clear in the course. What are the different projects that we will be doing in the course? So let's go to one by one and let's discuss about the things what we are going to do. Okay, now the first project that we are going to do in the course is with respect to Docker and Docker Compose. So like two different microservices will be there. One is, for example, I have taken as example as student store application, and the MongoDB application. In Docker, we will call these applications as containers in the form. They will be running inside the containers actually. Student store application will be having APIs. Okay, application programming interface. If you are a developer, you'll be understanding what is an API. Okay, so that's a contains this application contains APIs, and this MongoDB is a database. MongoDB is a database where the data which is sent by the student store application will be stored into it actually. And MongoDB port on which the MongoDB application will be running is 27017, and the student store application will be running on port number 8080. Now, student store application will be connecting to MongoDB application. Okay, they will be connected with each other, communicated with each other to store the data that is generated by student store to the MongoDB actually. So for this, we need different things that we are going to do with the help of Docker Compose. We are going to automate everything like creation of custom network, creation of this student application, okay, creation of MongoDB, port mappings, okay, and like deployments and port mappings to 8080 of my container port and 8989 port of Docker host. Like this is called server. Let's think Docker host as a server. Okay, so we are entirely creation of a Docker image for this student store application using multi-stage Docker builds. That's an industry standard way. That is the way the industry uses to create an app Docker images out of multi-stage Docker builds Docker file. Okay, we are going to do that. This is a multi-stage Docker builds Docker file. So out of this Docker file, we will be creating a Docker image of student store application, and we will run the Docker image as a container, and we will be storing the data to MongoDB, and we will be accessing that data, that student store application from the Postman. Okay, from the Postman. Postman is a tool where we can send the request to the application, and the request will be served by our application. This contains this sends the Postman is a tool which sends the request to our student store application, and the data will be stored in the database. Once the data is stored in the database, you should be able to see the data. You should be able to see the data, whether the data is properly stored in the database or not. That visualization of the data will be we will be using Mongo Compass. It's one of the tool, okay, where you can connect to the MongoDB application and you can see the data which is present in the MongoDB using the Mongo Compass. Okay, now everything will be automated. Creation of Docker image for student store application, creation of custom network, creation of volumes of and now yeah, container communication, and the Docker networking. Everything we will write in one Docker Compose file, and we will be deploying the applications into our Docker host, and they will be communicating with each other, and they'll be serving our traffic actually. So such kind of important project we are going to do. Everything that we are going to do is related to the real-time industry, how the people that they are using to deploy their applications onto the servers. In the same way we are going to do in this course actually. So this is the project number 1 that we are going to do. One is, this project includes most of the important Docker concepts. It includes Docker file. In the Docker file, we are including industry standard way of creating Docker image, that is multi-stage Docker builds. It's an important thing. Multi-stage Docker builds is an industry standard where the industry uses to create a Docker image out of that multi-stage Docker builds Docker file. Actually, that's the thing. And we are also including in this project Docker volumes. What is Docker volumes means? This data which is stored in the MongoDB should be stored somewhere, right? That is a volume, that is a storage. In Docker, we'll call as volume. Okay, that Docker volumes concept is also included in this project. Okay, Docker Compose, as I already mentioned, everything, creation of Docker image and deployment of this Docker applications, and creation of containers, and creation of volumes and port mappings, and creation of communication between the student store application and MongoDB application. Everything will be automated with the Docker Compose. In that way, I have included Docker Compose in this project. And Docker networking, as we are creating these applications, as we are deploying this application, student store application and MongoDB application into a custom network, we are going to create our own network, and we are going to deploy our applications onto that custom network. Actually, that is the networking that is included in this project. And container communication. Okay, this student store application need to be communicating with MongoDB application in order to store the data to the MongoDB database, and in order to get the data from the MongoDB database. This communication should be there between these two applications. So that also will be covered using the links option that we have. Everything will be automated with Docker Compose. You will be understanding how powerful the Docker Compose file is. If you want to deploy 100 different applications, you need to spend a lot of time without Docker Compose. If you are using Docker Compose, that's highly affect your time. Actually, with one command, your all the 100 applications will be deployed on your server. Okay, that's the power of Docker Compose that we are going to see as part of this project. And this is the project number 1 that we are going to discuss as part of this course. Okay, that's a project number 1. Okay, this is a project number 1. And next, this is the project that belongs to Docker. Okay, this is a project that belongs to Docker. And next project that we are going to deploy is regarding the Kubernetes. Okay, what we are going to deploy is this student store application, which we have deployed in the Docker host or the server, is like a container. The same application we are going to deploy in Kubernetes. Okay, we are going to use Kubernetes objects. We are going to use deployments in Kubernetes. We are going to use replica sets in Kubernetes. We are going to use pods. We are going to use services in order for the load balancing like this. Okay, this is called service. Okay, the service will be load balancing the traffic to the our applications. This is the student store application, and this is the MongoDB application. And MongoDB application will be connected to the AWS, Amazon Web Services. Like, it requires some storage, right, to store the data, right? That storage is provisioned using Amazon AWS EBS volumes. Actually, they are automatically provisioned. You no need of externally provisioning the volume. They will be automatically provisioned. Okay, in this project, I have included many things. Actually, in many things I have included deployments, replica sets I have included. Okay, I have included services. Okay, there are two types of services I have included here. One is cluster IP type of service, and the other one is load balancer type of service I have included. And the other thing I have included is persistent volume claims and persistent volumes I have included in this project. And the different things, resource quota I have included, like how much amount of CPU and how much amount of memory that you need to give to your application. Suppose your application requires 1 CPU and 1 GB memory. So that is the resource quota. That is a resource quota. You will be restricting your application to require to use that much amount of CPU and memory. Okay, that's the resource quota I have included. So namespaces, the configuring namespaces, this project, we are going to configure namespaces in Kubernetes. This second part we are going to deploy in another namespace. First part we are going to deploy in another namespace. Actually, now this, how the communication between the namespaces will be established, we are going to see using DNS service. Actually, so how the communication between the different namespaces, the applications that are present inside the different namespaces will be there. Actually, that we are going to see. We are going to after that is a namespaces. Now limits, we are also going to that means resource requests and limits. Okay, that we are going to configure with our applications. We are going to configure our applications with config maps. Actually, that is a way you need to configure your environmental variables to your applications in this project. And secrets, suppose your MongoDB application that you deployed as a part of this deployment, that requires some password need to be set, right? That is passed as a secret to this application. And horizontal pod autoscaler, that is secret, will be configuring with this project. Actually, horizontal pod autoscaler, right? Suppose this is the first day you have deployed your application to the server in the Kubernetes cluster. Actually, now what happened today is, today only 100 requests are coming to your application, only 100 people are using your application. But tomorrow your application is being popular and many people were requesting your application. Okay, based on the amount of requests, or that is based on the amount of incoming traffic to your application, your applications will be scaled enough to serve that much amount of traffic that is coming. That is the horizontal pod autoscaler that we are going to see. Automatically the pods, the replicas will be increased based on the traffic. If the traffic is more, the pods, the capacity of the application will be increased. The traffic is less, the capacity of the application will be decreased. So that's how the power of horizontal pod autoscaler, that one we are going to use in this project. Actually, now after deploying all these things, we can access that application from our web browser or the Postman. I have taken as a web browser, but you can also access from the Postman. Okay, from the Postman as well. Okay, now here what are the different objects of Kubernetes got included? Services, deployments, replica sets, pods, persistent volume claims, persistent volumes, and Amazon Web Services. These persistent volumes will be provisioning AWS EBS volumes, and resource quota will be increased, namespaces will be included, and requests and limits will be included, config map object is included, and secret is included, and horizontal pod autoscaler got included in this project. It's a combination of multiple concepts in the Kubernetes. This project is a combination of multiple projects in the Kubernetes actually. So that's the thing. And if if the here we also take the backups of our persistent volumes using jobs and cron jobs in Kubernetes. Jobs and cron jobs objects in Kubernetes were used to take the backups of our data that is stored in the persistent volume. Okay, so that will also be included as part of this project actually. So we are going to do the backups of our data that is stored in the persistent volume actually using cron jobs and jobs. Okay, all these things were included as part of this project number 2 as part of the course actually. Any questions do you anyone has regarding the project number 1 and the project number 2? Please, you can ask. It's open for questions now. You can ask the questions on these 2 projects, then we'll go further. Okay, any questions anyone has?
What is pod, sir?
What is
Pod. POD.
Can you repeat that? Pod. Pod is a way we will use. Pod is a Kubernetes object that is used to deploy our applications on the Kubernetes cluster actually. So in Docker we will say container, in Kubernetes we will say pod. Okay, that's a difference actually. It's a you can overall think as an overview, as a starting stage, you can think that as pod is your application. That's it. Okay, that's you can think of.
What is container, sir?
Container, this pod internally contains your container actually. So in Docker, we will call that one as container. In Kubernetes, we will call that one as pod. Inside this pod, the container will be there. Inside the container, your application will be running. That's how the container is there actually. So that's the thing. Container is a, like in real time, like in your normal life, what is a container? It is used to ship the goods from one place to another place, right? In the same way, our container will be in the Docker or in the Kubernetes. The container is the container in which our application will be in running state actually. That is a thing actually. That's a container. And this is in Kubernetes we'll call as pod, and there we'll call as container actually. But in pod, in Kubernetes, we can have multiple containers. Okay, in pod, in Kubernetes, we have multiple containers that we'll see in the course actually. So that's a thing.
Can we host multiple applications in a single Kubernetes?
Can we host multiple applications in single
Kubernetes?
Yes, you can host multiple applications in single Kubernetes cluster. Those are called microservices. People will be using that. So multiple microservices you can deploy on single Kubernetes cluster. That is right. You can do that.
Linux is mandatory for this one?
No, Linux knowledge is not mandatory for this one. Few commands as the basic commands like ls or touch command. What is a touch command? Is used to create a file. Ls is command is used to list the files, and such command basic commands will be anyway we are going to use that commands in the course. That time you will be familiar. But if you know prior knowledge some basic commands, that will be enough for the course. That's it.
Sir, what are all the prerequisites we should have before joining the courses? Like, do we need to set up all Docker and AWS accounts creation, everything? We should do it before this?
No. The only prerequisite that you will be having is the creation of AWS account. That's it. Okay, because you can also do in your local laptop. That does not if you do these projects in your local machines, what will happen is these are Docker and Kubernetes are huge softwares which can take your much amount of CPU and much amount of memory from your local machines. That may affect your other applications that are running in your local machine. That is the That is why I suggest every batch to create an AWS account. It's 1 year. 1 year. It's 1 year is a free. Okay, so that you can use the AWS account and use create this project and practice the contents what we have discussed in the course there in the AWS account actually. So that's the thing. Okay, that's only prerequisites that is required of creation AWS account. Okay, but that also I will be showing in the course how to create an AWS account, and if any things are required in the AWS account like creating servers, that also show how to create a server, and that's things whichever required to create like to whichever required to do this course. Okay, creation of servers and creating the Kubernetes clusters. Okay, everything I'll show in as part of this course actually, which are required within the AWS actually. That's the thing.
Should we
So
have
what
a
is
clear
Docker image?
programming language?
1 second, can you repeat that?
Should we have a prior programming language before joining?
No prior programming language is required, because we are not covering any programming language here. We are covering how to create a Docker image from your application. That's it. Okay, that's entirely the application will be created by the developers itself. We don't do any programming language things here. No need of having the programming language knowledge. Okay,
This is related to infrastructure, am I right, sir?
Not exactly, because this is related to deploying of your applications in an automated fashion. Okay, how the industry deploys your microservices on through the servers. Actually, infrastructure means creation of servers. Okay, that is different. This is Docker, Kubernetes, and Jenkins related to deploying, automating, and securing your applications that is being deployed on the infrastructure. That's the thing.
What is
The
Docker
config-
image, sir?
One at a time, please.
Okay, I will
Anyone
go
go ahead. Yeah.
Like config files and all will have a indentation languages like on this. Will you be teaching us in detail what's the namespace, board, and what and all the details we use, memory, and all the details in detail?
Yes, in detail will be taught actually. Those are the Kubernetes things. What are pods? What are namespaces? And if so, see in this course, you need to write manifest files. That is a declarative thing. That's YAML scripts you need to write. That's very easy. It's not a programming language. It's not a programming language. It does not contain any logic. Okay, it's just a declarative thing that also will be taught in this course. Okay, the everything secret, config map, limits, and resource quota, namespaces, horizontal autoscaler, pods, deployment services, different types of services, and persistent volume claims, PVs, and replica sets, and everything will be taught in this course. That's the thing. You will get industry standard knowledge. I mean to say, that's the thing.
Okay, like even the secret manager where we store the credentials and all that as well.
No, we are not going to store the credentials in secret manager, AWS secret manager, as you say, because that's an AWS thing. We are going to store the secrets as part of secret object in Kubernetes. See, secrets manager of AWS is different and secret object of Kubernetes is different. Okay, so see, we are going to store the credentials as part of secret object in Kubernetes. That's the thing.
Okay, and also sometimes we get errors and all. How do we analyze the errors? And that part will also be covered, right?
Yes, that's an important part that should be there. The knowledge should be there with you. If any problem occurs, you need to understand where the problem has been occurred, whether it's with the Kubernetes cluster or whether it's with the application. If it's with the Kubernetes cluster, how to solve that? What's the first step you need to take? And if you after the first step, what is the second step you need to take? After the second step, what is the third step you need to take? Okay, like that in a detailed manner. If this problem occurs, what might be the cause of this problem? Okay, if this problem occurs, what is the solution for this problem? Okay, if this problem occurs, how to contact, whom to contact? If the problem is with your application, whether if it is actually with your application or whether it is a communication between the applications, such kind of related troubleshooting will also be explained very, very clearly and very in detailed manner. Okay, that's the thing.
Okay, do we get the recordings and study materials?
Yes, you will be getting the recordings and study materials. You will be having 6 months of access to those recordings. You will be getting the drive access so that you can go there and practice that. Okay, that's the thing.
So what is Docker image?
Docker image is something like a binary. Okay, as this is the starting as what, just think for an example, you want to play a game, right? If you want to play any game, you will be downloading some .exe file from the internet. What the .exe file contains? Your actual game, right? When you double click on that file or the downloaded thing, the game will be started, right? That means when you download that file, that in that file the game will be there, but not in running state. Okay, in the same way, Docker image is a binary, like a binary you downloaded for the game. Okay, it's a binary in which our application will be present, but not in running state actually. So that is a Docker image that we call it as. Okay, that's the thing.
What is CI/CD pipeline?
CI/CD pipeline we are going to discuss as part of 5th project. Okay, this is second project. So CI/CD pipeline is an automatic way of deploying our applications to the Kubernetes cluster. It's an automation that we do with the anything, not only Kubernetes. It's an automation with Terraform. It's an automation with Kubernetes. It's an automation with Packer. Also, it's automation with Puppet. Okay, that's CI/CD pipeline. It's continuous integration and continuous deployment of our applications. Actually, that's the thing.
What's the difference between Docker and Kubernetes?
See, the difference between Docker and Kubernetes is Docker give less it gives very less functionality for us. We can only deploy the applications as containers. That's it. It cannot. In the Kubernetes, it's a container orchestration technology. Suppose, for example, I can tell you, if you want to pass a secret for the in case of Docker, you need to directly pass a secret for that while running the Kubernetes Docker container. But in Kubernetes, we will be having a secure way of passing the secrets to your applications. Like secret object will be there. So extra functionalities will be there. That is a container. Kubernetes is a container orchestration technology that we have actually, but not Docker. So some extra functionalities will be there. Okay, deployment strategies will be there, like horizontal pod autoscaler, like this kind of object, this kind of functionality will not be there with Docker. If the traffic increases in case of Docker, the containers will not be scaled. Okay, like your traffic increases, then the container will not be unable to satisfy that much amount of traffic. But in Kubernetes, if the traffic increases, the containers will be automatically scaled without any manual interaction. So the if the traffic got decreased, and the containers will be automatically drop down to the very less number based on the traffic. The Kubernetes cluster can act as it is. Okay, that's the thing. That's the difference between. There are many differences, but some of the differences I can discuss as of now. Okay, because we are going to see as part of that course. Okay, but what the main difference is, Docker will not give that much amount of flexibility for us, but Kubernetes, it's as is a container orchestration technology. We have multiple strategies that we follow in Kubernetes that give much flexibility, much functionalities to our applications for zero downtime. Actually, that's the thing. That's the difference. Okay.
So what is Jenkins?
Jenkins is a CI/CD pipeline tool. It's a continuous integration and continuous deployment tool where we automate our applications deployment to your servers. Actually, so there are many tools like that. Jenkins, GitLab, or there are many tools like that. But Jenkins is the popular tool in industry. That's a continuous integration, continuous deployment tool. That's the thing.
What is Helm?
No, we are going to discuss about project. Helm is a package manager for the Kubernetes. Okay, we are going to automate the deployment. See, all the infrastructure, like all the applications, we are going to create as templates. Okay, like in the Helm, that's a part of project number, I think 4. Okay, that we are going to discuss at project 4 actually. So that's the thing. Helm also included as project number 4. Helm, Argo CD, and K9s, Kubernetes dashboard. We will discuss the coming projects are that one. Okay, so pipelines will be there. That's the thing. Okay, so yeah.
What's the difference between DevOps and ML Ops?
MLOps is entirely for machine learning, okay? Machine learning related applications. I don't know what machine learning activities will be there, but DevOps is a development and operations. You are in the DevOps. What you will do is you will be developing scripts, okay? You will be developing some scripts. It's not a applications or nothing, okay? It is some scripts like Terraform scripts, Python scripts, Groovy scripts. In order to automate your regular activities, that is comes under development in DevOps. And operations in DevOps represents like maintaining the created infrastructure, like providing security updates, okay? Now or like providing the OS updates, regularly deploying the new version of the applications to the servers. Such kind of operations comes under operations activity in DevOps. DevOps is a combination of development as well as operations. That's the thing. Okay, that's a DevOps. So this is the project number 2. Someone put something in chat. One second. Yeah, I hope this is been answered. Okay. Yeah.
Yes, sir. So what is Azure DevOps and AWS DevOps? Is there any differences?
Difference is nothing. Whatever the functionality, the functionality is same, but you are in the Azure DevOps, you will be using Azure related tools. Like Azure services will be different. They will be called with different names. But AWS DevOps, you will be using AWS related tools actually, like continuous code commit, code deploy, code pipeline. So something like that. That's a difference actually. In Azure DevOps, you will be using Azure tools, and in AWS, you will be using AWS tool. But end product, okay, but end product will be same. Deploy functionality will be same. I mean, end product means functionality. What you are going to do will be same actually. That's the thing. No, that's the thing. Yeah.
Yeah, actually, just now I joined actually, so I really don't have any idea what is already been discussed. So, is it like the demo is for the seminar on Jenkins or Docker Kubernetes for one day, or is it like demo class for any batches actually?
No, the seminar is for today actually. We are going to see the different projects that we are going to use that we are going to do in the course in the seminar. That's it. Okay, the seminar is only for today. The demos will be started from tomorrow. What the course content and what we are going to discuss in the course, and different concepts that we are going to do, and which are the things you need to mainly concentrate. And the demos will be started from tomorrow 9:30 a.m. Okay, that's the thing. Okay.
9:30 a.m.
Morning, yes.
And the course content will be Jenkins, Docker, and Kubernetes.
Yes, course content will be Jenkins, Docker, and Kubernetes. Yes.
Okay. And what about the duration?
Duration will be 45 days. Okay, without weekends. Okay, you should not include weekends. Okay, it's Monday to Friday. That's the thing. 45 days.
Any idea about like the course fees?
What?
Any idea about like course fees actually?
I did not get you. Your voice is little bit
Yeah,
it's
is
breaking.
it audible right
now? You are audible now.
Yeah. So what I'm asking, like, what about the course fees for this course?
Can you put that in chat, please? Can you put that in chat? Your voice is breaking, please.
Mention in the chat 6,000.
Okay, course fees. Okay, sorry, the course fees. Okay, that's 6. That's the thing. You can find it in DURGASOFT website. Okay, that's the thing.
Sir, what will be salary after doing this course?
See, I cannot decide the salary, what you are going to get,
no,
but
means range, sir.
You will be as experience of 5 years of using Docker and Kubernetes and Jenkins after joining. I can tell you that assurance, but that's entirely in your hands, the salary thing, because I cannot firstly tell that entirely the thing actually. So you will be as experienced as 5 years of experience in Jenkins, Docker, and Kubernetes. Okay, that's a thing I can say.
So from a developer perspective, like, is it advisable to go for Jenkins, Docker, and Kubernetes?
sorry, put that question in, please. Please put that question. Please, if you don't mind, please put that question. Your voice is breaking for me. I don't know why, but yeah.
So any other timing, because I have already some another classes from 10 a.m.
Sorry
this
for that. We don't have any other timing because one batch is running in 8 a.m. So it's already Docker got completed there, but no other batch
for
we
after
have
this
planned.
batch,
So
sir.
after this batch, yeah, we will be planning after this batch after 48 days. Okay, after completing this batch. Yes. Okay, so this is the project number 2 that we are going to do as part of this course actually. Now project number 3, okay, project number 3, some extra configurations that we are going to do in as part of, as we go further into further projects, the projects will be as complex as it is, because we will be familiarizing with the things in the project number 2 itself, some of the things, and in the project number 3 we are going to add some more things. Okay, like that we'll be increasing the complexity of our projects little bit, okay, something like that, so that you'll be able to know the how the things are working. So in the previous projects we have used horizontal pod autoscaler, secret, config map, limits, requests and limits, namespaces, quotas, okay, resource quota, I mean to say. Here we are also going to use role, RBAC, that means role based access control. If you are able, suppose in your organization multiple people will be there, multiple teams will be there, okay, testing team will be there, okay, testing team will be there, okay, developers team will be there, DevOps team will be there, and administrators, some different teams will be there. So all the people, all the different teams people should not have or entire administrator access to the Kubernetes clusters, right? So they should not perform anything they want. Actually, developers should be able to only view the applications in Kubernetes cluster. Only view access should be given to developers. Okay, testers, if the tester should only be able to test the applications in the Kubernetes cluster. Okay, so administrators should be having the full access in the Kubernetes cluster. DevOps people, okay, should be having the limited access in the Kubernetes cluster to particular names, to particular applications, something like that. Okay, so how do you manage this access related things between different teams or different people in Kubernetes? That is with the role based access controls, which is there with the Kubernetes, that is included as part of this project. As part of role based access control, role binding, cluster role binding is included as part of this project 3 actually. Now other things that were included in this project 3 are ingress controllers as part of networking in Kubernetes, because your projects, your applications, your microservices will be having different APIs, right? Suppose let's think your microservice, this is the first microservice that you have deployed, okay, this is the second microservice that you have deployed. This second microservice has API named demo, okay, the first microservices has the API named test, right? Based on the API path based access actually, we will say, based on the user send, suppose the user request /test from his web browser, then the request should go to this microservice. Okay, if the user request with /demo API, then the routing should happen to other microservice like this. Okay, if the it's based on the API, okay, it path-based access, actually path-based routing, we will call it as in Kubernetes, that can be achieved with the help of ingress controllers in Kubernetes. Okay, we are going to see ingress controllers. We are going to see 2 types of ingress controllers in as part of this project actually. So one type is Kong ingress controller, other types is Nginx ingress controller. So there are many ingress controllers that Kubernetes supports, like API 6, okay, STO it supports, GluE it supports. So it's like that. Okay, many ingress controllers are there with Kubernetes, but we are going to see the important ingress controllers, that is Nginx ingress controller and Kong ingress controllers, with which we are going to do path-based routing. Okay, that is the project number 3, based on the path. Okay, based on the requested path /test. Okay, the routing, the traffic will be routed to one microservice. If the request comes with /demo, the traffic will be routed to different microservice. So such kind of routing functionalities will be given to us with the Nginx and the Kong ingress controllers actually. So the extra configuration that we are going to do as part of this project is role-based access control as part of security, and as part of networking we are using ingress controllers, Nginx ingress controller and Kong ingress controller actually. So that's part of networking, that's part of security. I have included in this project number 3 actually. You may ask what's the difference between Nginx ingress controller and Kong ingress controller, right? So Nginx both serves the same. Okay, the support might be different from them. Okay, like both can satisfy path-based routing, both can satisfy host-based routing. What Nginx can satisfy, that can also be satisfied by Kong, and what the Kong can satisfy, that can be satisfied by the Nginx also. But the difference is the support they give from their the developers that they developed these controllers actually. So Nginx is by Apache. People trust more Apache, so the people uses Nginx. If the people trust more Kong, the people uses Kong based on their requirement. Based on their requirement, they will using whatever they want actually. So that type of that functionality that we given as part of project number 3. The extra thing that I have included is security and networking with the help of role-based access controls and ingress controllers and path-based routing that we are going to do here actually in the project number 3. That is a project number 3. And if you have any questions with the project number 3, please go ahead. Please go ahead.
Sir, what is controller?
It's an ingress controller. What is a controller means? It supports the path-based routing. Suppose we have different microservices that we will deploy into the Kubernetes cluster actually. So if you deploy, it's a software which supports the path-based routing based on the requested path from your web browser actually. So that's a separate software or the application that should be deployed to the Kubernetes cluster to support path-based routing actually. That's an ingress controller that we call it as. See, this is as part of this webinar, I'm explaining the projects, but everything will be clear in the course because you need to understand what is pod, what is service, what is the different things, so that it will be very clear for you. As this is a webinar, I'm explaining the projects. Okay, that's a different thing that we are going to do. That's the thing. Okay. So yeah.
Okay, is controller necessary for the microservices?
Yes, people in real time do not directly send the traffic to microservices directly. They will use some ingress controller between them. If you see, there will not be any path-based routing if you don't use the ingress controller. People in the real time uses ingress controller, and that is necessary. Okay.
So Ravi, like when are we starting doing Jenkins?
Jenkins, see, after Docker and Kubernetes, we are going to start Jenkins, okay? Because we are going to do the automation with Jenkins, right? Whatever the things we learned in Docker and Kubernetes, that will be automated with Jenkins. First, you should know what is Docker, what is Kubernetes, then only you can automate with Jenkins actually. Then that is why I put that Jenkins at last place.
Okay, got it. Thank
you. Thank you.
Sir, what is the advantage of Docker over Kubernetes?
Yeah, that's what I tell you, right? So you are going to get some extra functionalities. That is a container orchestration technology. See, in Docker, you are not going to get horizontal pod autoscaler. In Kubernetes, you are not going to get resource requests and limits in Docker, but in Kubernetes, you are not going to get like policies in Docker. You are going to get in Kubernetes. So there are many differences between the Docker and Kubernetes. This Kubernetes, it's a production level cluster actually, but not Docker. Docker, you cannot directly use in production. But because that if something is gone wrong with Docker, your production applications will be entirely down, but not with Kubernetes. If something wrong with Kubernetes, automatically new applications will be automatically deployed, okay, without you manually interacted with it. If your application is deleted, a new application will be automatically deployed by the Kubernetes cluster, actually Kubernetes master node automatically. It's a zero downtime we can tell with Kubernetes, but not with Docker. Actually, that's a difference. The main difference is we'll get some extra functionalities with the Kubernetes, but not with Docker, and Kubernetes will be used in production, but not Docker. Actually, that's the thing.
Sir, what is the advantage of having Docker then?
See, Kubernetes will internally uses Docker. Okay, Kubernetes. See, what I can tell you as of now is these pods which we have doing here. I have told you, right? We will be deploying our applications as pods in the Kubernetes cluster. The pods internally contains containers. You should first know Docker containers first. What is a container? Then Kubernetes will be internally using containers actually, so that you will be that will be helpful for you in debugging things. Okay, it is not something like you are not entirely ignoring the Docker. Kubernetes internally uses the container runtime engines like Docker. Actually, without Docker container runtime engines, Kubernetes will not work. Okay, that may be any container runtime engine, not only Docker. There are many container runtime engines in the market. Container D is the example. Rocket is the example. Okay, Cryo is the example. Okay, Kubernetes may use any of these container runtime engines in the backends to support their applications. Okay, that's a thing actually. That is why you should know Docker. Okay, that's a thing.
Okay, sir.
Yeah.
So here I have one doubt. So as you mentioned, for example, one of the application is deleted in the production. So automatically in the Kubernetes, one more application will be created and the production won't go to down. So how it will possible?
It is possible with the help of deployments in Kubernetes. We'll having something called deployments. In the deployments, what you'll configure is you will configure at any amount of time this many number of pods should be running, okay, in my Kubernetes cluster. If any pod got deleted, okay, your pods will be running. If any pod I wantedly deleted one pod, the deployment in the Kubernetes cluster automatically detects that someone has deleted that pod in the Kubernetes cluster, and deployment in the Kubernetes cluster will be automatically deploys new pod, and that means the new application will be deployed. That is entirely possible with the deployment in the Kubernetes. Actually, that is an internal functionality that Kubernetes gives for us. Actually, that's the thing.
So here means all the pods having the same functionality, right?
Yes, the applications may be different. The internal applications that are running in the pods may be different, but the functionality which is given to us by the Kubernetes will be same for all the pods. Actually, that's the thing.
Okay, thank you.
Yeah. Yeah, in the project number 3, as I said, security networking got included from the project. That is the difference between project number 3 and the project number 2 actually. Now let's go to project number 4. Okay, in this project number 4, what we are going to see is, one second. Yeah, this is the project number 4. Whatever we do in the project number 3 and project number 2, actually, we are going to convert that projects as Helm charts. Actually, we are going to convert that projects as Helm chart. We are this project, the project number 3 and project number 2, we are going to deploy as a Helm chart into the Kubernetes cluster, and we are going to connect the Kubernetes cluster to K9s dashboard and K9s dashboard. This is a client side tool, and the K8s dashboard, this is the server side tool. That's the difference between K9s and K8s actually. So these are the different tools where you can visualize your applications, whether your applications in what state that applications are, whether they are in running state or whether they are in any issue state. Okay, you can visualize like this, how many in the form of graphs actually. Now in the project number 4, I have included Helm and the dashboards such as K9s and the K8s dashboards, where you can visualize your cluster and the automation. This is an important thing. The that I have included in the project number 4, that is Argo CD. Argo CD, GitOps way of technology, where our applications will be deployed automatically when there is some changes that is happened to the manifest files in the GitHub. Actually, suppose we will be having something called manifest files to deploy our applications to the Kubernetes cluster actually. So if that manifest file got changed in the GitHub, that Argo CD will be automatically detecting that and automatically deploys the updated changes in the GitHub to our Kubernetes cluster without we manually interacting with the Kubernetes cluster, without we manually deploying the changes to the Kubernetes cluster. That is taken care by Argo CD. That's a continuous deployment of our applications to Kubernetes. That's a thing that we are going to cover. Is it Argo CD? There's an alternative to Argo CD, something called Flex CD, but that is not popular as of now. But Argo CD is being popular nowadays in industry. I have included as part of project number 4. I have included 4 things actually. One is Helm charts, okay, Argo CD. Other one is Kubernetes dashboard connection to Kubernetes cluster, and K8s dashboard, where you can visualize in the form of graphs actually how many pods are running, how many pods are having issues, and something like that. Actually, that is part of this project number 4 I have put actually. So that's a project number 4 that we are going to do as part of this project. Okay, that's the thing. Any questions you have with project number 4? Anyone has any questions, please?
Yeah, hi. Am I audible right now?
Yeah, but it's not very clear. Voice is not very clear. Sorry for that. Sorry for saying that, but
Okay,
yeah,
okay.
voice is not clear. Yeah. You can post your question in chat, please, if you have. See, these are all the tools which is really used in the industry. Okay, so we are concentrating on industry way of using Docker, Jenkins, and Kubernetes actually. So what are the different things we are using the things in the industry? In the same things we are going to use here, you'll be getting the industry standard knowledge. Okay, something like that. Okay, something like that. Okay, one second. Yeah, that's the thing. That's a project number 4. If you have any questions, you can ask. If not, we are going to project number 5. Okay. Okay, if no questions, let's go to project number 5. Okay, now we will be in the project number 5. We are going to create entirely a Jenkins pipeline. See, these are just a projects we are going to do, but there are many things involved, many concepts involved in it. Okay, after learning those all concepts only, we are going to do the projects actually. So we are going, I'm showing you now the end products, what we are going to do, so that you will be like you will be interested to join, like you will be interested to see that actually. Now in the GitHub, see, developers, what they will do, they will be developing the code and pushing their code to the GitHub repository here. Once they push their code to the GitHub repository, Jenkins comes into picture as part of their development. What they'll do, they will develop the application as well as they will write that unit test cases for their application. That may be in anything actually. They will use some frameworks like JUnit, Mockito, and PowerMock, something like that. They'll use, that's their problem, but they will be using those frameworks in order to write unit test cases actually. So once they push their code to GitHub repository, that GitHub repository will be connected to Jenkins. Okay, the Jenkins, what they'll do, what here the pipeline starts actually. This is the first stage of the pipeline, the code checkout. The code will be downloaded from the GitHub repository by the Jenkins automatically. The code will be downloaded to the Jenkins but automatically from the GitHub repository. Once the code got downloaded, suppose I am taking an example, a Springboard Maven project actually, which is Springboard project which includes the Maven builds actually. So Maven as a build tool. Now Now, once the Spring Boot project is pushed to the GitHub repository, Jenkins will download that Spring Boot project to its machine, and that means its server where the Jenkins is running. Now, that will execute Maven package command that it builds the project. You cannot directly put the project onto the server. It is not going to work. You need to undergo many steps in between actually. First, it builds the project that been checked out from the GitHub repository using Maven. Okay, that is going to use Maven, some of the Maven commands like Maven package, which will create a jar file. So we are going to do everything in this course. Okay, so that's a Maven we are going to do. Once the Maven build has been completed, once the jar file got created, it is going to execute. This pipeline is going to execute unit test cases. If any unit test case fails in the middle, the pipeline is going to be failed actually. So that's how that will work actually. All the unit test cases will be executed in the Jenkins pipeline. It is for the initial testing of our applications developed by the developers only. We don't develop that. Okay, unit test cases as well. Now that's a unit test cases that will be executed as part of next step in the Jenkins pipeline. Once the unit test cases is executed, now the next step is the Sonar Cube. This project which is being checked out will be connected to the Sonar Cube. What is this Sonar Cube tool? Sonar Cube tool is something like it's a vulnerability check. Like your application code might be containing some of the bugs, okay, some of the problems that will be detailing to you, that will be analyzed by the Sonar Cube actually. Sonar Cube will be checking the vulnerabilities, and some extra things will be there with the Sonar Cube, but that Sonar Cube will be integrated with our Jenkins pipeline to check the vulnerabilities with our project, with our program or the code or like that. Okay, that's a Sonar Cube that we are going to include. Once the Sonar Cube step got completed in the Jenkins pipeline actually, now we are going to store the artifacts into JFrog. Artifacts is nothing but a zip file. Now, suppose if you want to send a 10 files to your friend, what you'll do, you will convert that 10 files in zip format, and you will be sending that zip file to your friend, so that your friend will be downloading that zip file and extracting the 10 different files, right? In the same way, here our entire project is converted as zip file, like jar file that we call it. That is called artifact. In the case that is zip file which you convert from 10 different files is called artifact actually in the case of this. So that artifact will be pushed to the JFrog. JFrog is used to store to the JFrog is used to store the artifacts actually. That is JFrog. Once the JFrog step got completed in the Jenkins pipeline, now Trivy actually, once the JFrog step got completed, now Docker image will be building in the Jenkins pipeline out of the project which the developer is pushed to the GitHub. The Jenkins pipeline will be building the Docker image. Okay, that Docker image will be scanned for the vulnerabilities using Trivy actually. That Docker image will be scanned by the Trivy for any vulnerabilities in that actually, for any bugs related things. So that's a Trivy we are going to scan actually. Once the Trivy step got completed, the image will be pushed to Docker Hub. Docker Hub is the one where we store all the different Docker images actually, where we store different Docker images of our applications. Once the Docker Hub, once our image got pushed to Docker Hub, then the next step, the image version will be updated in the GitHub repository again. The image version will be updated in the GitHub repository, and once the image version got updated, that will be detected by the Argo CD, which is deployed in the Kubernetes cluster. Then it detects the change in the GitHub repository, and that will automatically deploy our application to the Kubernetes cluster, the changed application to the Kubernetes cluster. This is how we will automate the related things. See, once this pipeline is built by the DevOps engineers, see, then the changes will be pushed to the developer. All the things until the deployment of that changes to the servers in the Kubernetes cluster is automated. Entire thing is a full-fledged automation that we are going to do as part of this course. Okay, this is a full-fledged automation that we are going to do. Once this has been done, once this everything is been set up, developers will just push their code, just update their code and push their code to the GitHub repository. Until the deployment of that code to the Kubernetes cluster, everything is automated. Actually. And this is that project in entire automation, what we learned as part of Docker and Kubernetes. Entire things will be automated with the help of Jenkins actually. Now, here, the important thing that we are going to cover in this Jenkins project is shared libraries. Okay, shared libraries is one of the industry standard. Okay, is one of the industry standard tech like concept that the people uses. See, multiple Jenkins pipelines will be there in the Jenkins console. Actually, if the multiple Jenkins pipeline uses the same code, why to write same code multiple times, right? So what the people did is they have created something called shared libraries, and the same code will be used by multiple pipelines. So shared library will help us for the reusability of our Jenkins scripts, actually pipeline script. Okay, that is for the shared libraries. So that's an important thing, that's one of the important thing that we are going to cover. The other important things which we will be covering as part of this pipeline, as part of this final project number 5. Actually, that's a thing that we are going to cover. Actually, if you have any questions, it's open to questions. Please ask your questions, please.
So here, what are the roles for Docker and Kubernetes?
Yeah, the roles for Docker and Kubernetes comes from after JFrog step, because from the code which is pushed by the developers, right, the Docker image should be created. After this JFrog step, the Docker image will be created with the help of Docker, and the Docker image will be deployed to the Kubernetes cluster with the help of Argo CD. So the roles will be creating of Docker image and deployment to the Kubernetes cluster. That's the thing. That's a automation that we are going to do with the Docker and Kubernetes with this Jenkins pipeline actually. So that's the thing.
So are we going to get any help regarding for how we can mention all those things in our resume and in the projects?
Yes, you are going to get an help. Okay, I am going to tell you how you can mention your projects, or how we can going to help you in your resume. I'll be sharing some of the templates how to mention these things to you, so that you can use that templates. And if you have any doubts, you can ask. So you are going to get any help. You will be going to create a Telegram group, and you can post there, or yeah, you can get help from in your regular classes as well. So something like that, you can get that. Okay.
Thank you.
Yeah.
Yeah, is it audible right now?
Yeah, I can manage. Please ask your question.
Yeah, actually, I just wanted to know, like, being an backend developer, is it advisable to go for this course actually?
Developers, can you repeat that, please? Please, don't mind. If you don't mind, please put that question in chat, please. I can read that.
Yeah. Is it audible right now?
See, it is audible for me, but it's some kind of disturbance, so something like that. Sorry for that, but yeah, maybe the problem with the headphones. So yeah. Put your question in chat. Yeah, is it advisable to go for this course as a backend developer? Yes, it's really advisable for the backend developers only, because people in the industry are expecting for the backend developer Jenkins, Docker, and Kubernetes in the wherever you go in your regular day-to-day work activities. And if you attend any interviews, people are expecting the backend developers to know the knowledge of Docker, Kubernetes, and Jenkins. It's advisable for you because you need to understand how the things will be developed. You will be developing the applications, how they will be working in the Kubernetes cluster, okay, how they will be deployed, what are the different configurations. You need to understand. If someone says that is problem with your application, but if you don't know the knowledge of Kubernetes, you'll really not able to understand whether it's the problem with my application, because your application in your local machine will be properly running, but the problem is given there in the Kubernetes. But you should be able to, you should be in the stand to understand whether it's a problem with the Kubernetes or whether it's a problem with the application, so that you can explain the people who have said the problem with the application. You can explain that like it's a problem with Kubernetes, not with the application. My application is properly running in my local machine, and you can check this one. Yeah, that is advisable for the developers. That's very important for the developers to get the knowledge of Docker, Kubernetes, and Jenkins. Actually, that's the thing. Okay, is that clear? Is that clear, please?
Yeah. So one more question actually I'm having.
It is a little out of subject. Which version of Java one should use to go for certification looking for at current market? Yeah, this entirely related to Java, because yeah, I cannot suggest this because I'm not previously I'm a Java developer. I'm not doing the Java development as of now, but yeah, I cannot answer this because I don't want to give the wrong answers. Okay, so yeah, because you are asking for about Java certification, or I think you are asking about Java certification. Okay.
Yeah. Actually, I'm asking for Java certification. Actually, I was planning to apply for one certification. So just asking.
Yeah, I cannot answer that. Please don't mind. Yeah.
Okay. And what about that Jenkins, Docker, and Kubernetes? That time frame. Actually, how many classes you have been split it? Like how many classes for Jenkins, then Docker, then Kubernetes?
See, Docker, it's something like 8 to 10 classes, and remaining classes with is Kubernetes and Jenkins actually. So this, see, Docker anyway we are going to use in Kubernetes, but we need to spend more time on Kubernetes and Jenkins. That is why I'm taking more time on Kubernetes and Jenkins. It will be very clear Docker also. So that's a thing actually. So that's how I split actually because of that.
Okay, that's all from my side. Actually.
Yeah. Okay. Anyone have any questions? Please go ahead. And if no questions, please join for the demos tomorrow, and we'll meet tomorrow class. Okay. Thanks.
Thank you.
Thank you. Bye.